Good afternoon, high school seniors. My name is Thomas, and I'd like to thank all of you for taking time out of your busy day to attend this assembly. Out of all the possible majors that you can choose in your future college career, I would like to give you a glimpse into the path of a physics major. As a theoretical physicist myself, I can guarantee that if you love problem solving and are interested in pursuing a career that is centered around discovering some of the most mind-bending phenomena observed in nature, that I truly believe a physics major is right for you. So many fields of physics have accumulated over the years, and I would like to share with you three of the many subjects that will be introduced to you if you do choose physics as your major. These three branches that I'll be discussing today include classical mechanics, special relativity, and quantum mechanics. I would also like to explain how students learn to approach tackling these concepts in an effective manner. So, learning mechanics is the first step for any physics major. Mechanics can be summed up as the relationship between mass, acceleration, and force. So, students start out with mechanics because it has very broad application and it's very intuitive. And I mean, it's intuitive in a way where, for example, if I were to throw a ball up into the air, my intuition would of course say that, oh, the ball will come back down. But now with the addition of mechanics, what this does is it gives a mathematical construct to add to my intuition, and so which once you convert a concept into mathematics, you now have very strong predictive power. So instead of just saying, oh, that the ball will come back down, you can predict exactly how long it'll take before the ball hits the ground, or exactly how high it will get. And so after you've had a very strong foundation in mechanics, you'll go on to some more advanced subjects, and one notable one is special relativity. So studying special relativity is the point of a student's career where they realize that the universe works in ways that could be very strange and unintuitive. It teaches that objects traveling at different velocities begin to experience inconsistencies with the overall passage of time. In short, the faster an object is traveling, the slower time passes for that object relative to its surroundings. So students used to think that the flow of time is universally constant due to how time is presented in their classical mechanics equations, but now they learn how to make changes to these equations in order to account for such things such as time dilation in an accurate way. So after a student has completed sufficient mathematical courses, then they can go on to quantum mechanics. And this is the subject that shows atoms behave in ways that are downright bizarre. Although atomic behavior is hard to believe, countless experiments verify the theory to be correct. And it teaches that the smaller a particle is, the less it starts to behave like an object, and the more it starts to behave as a wave distribution. So the particle no longer has an exact position or an exact shape to it. All intuition is pretty much thrown out the window when attempting to predict such an abstract predict results to such an abstract concept. You pretty much have to forget about your intuition, and students learn that they have to 100% just rely on mathematics to guide them through the problem-solving process. So, although mastering such concepts altogether can be very difficult, it can also be very gratifying. Being introduced to such material gives students a more comprehensive understanding of the fundamental laws governing the universe, as well as new problem-solving perspectives. If you choose to major in physics, you will be exposed to some of the most fascinating types of problems that students study today. Many companies are in high demand for problem solvers, which will make you very highly competitive in today's job market. Studying physics as your major will also give you the tools necessary to participate in the technological advances of the future. Thank you.